11E, ladies and gentlemen. Yes.
So short.
Oh my gosh, I could cry.
All right, ladies and gentlemen, so 11E is trigonometric equations in quadratic form. So this is taking what we did in 11A3 where we had equations that we solved algebraically and adding in the 11C2 with the factoring stuff and going from there. There may also be some of those relationships that we have to substitute. So, you might see double angles, or you might see one of those variations of cosine squared plus sine squared equals 1. There's really a lot of different stuff. So having your formula packets out just in case we need those relationships, but also having your unit circle out for the solving part will be important today. The notes are pretty short. Did everyone get the title? Zoomed in a little bit bigger? Okay. Stop at. So here we go. There's not a lot of note taking. It's mostly just let's get some examples and let's work with this. So it says 2 cosine squared plus cosine x minus 1 equals 0. And so one thing you want for sure, and we're going to see it more on the next example, but you want to make sure these are the same trig function, like both tangent, both sine, both cosine. If you have it mixed up, you want to do some kind of substitution with your relationships so that it's all the same. So now there's a couple of different options depending on your comfort level. If you felt pretty good with all that factoring in C2, you can go ahead and factor this right away. But if that left you feeling kind of funky, remember, you could sort of switch this into just having x's. So you could have 2x squared plus 1x minus 1 equals 0. So instead of cosine, I just wrote x instead, both of those times. But it's really just up to you. How many of you guys preferred substituting x in there like I have in red? How many of you guys were like, whatever, I can just leave it with cosine? Okay, looks like most of you feel like that. So either way, and I can do both, we have to multiply the coefficient to the first one times the last one. So either way, we would have to get -2. And then you think of factors of -2 that combine to equal 1. So what are those factors of -2 that will equal 1? Was that 2 and -1? All right. I'm looking at my notes and I see I definitely did it this way because it was a little bit easier for me, but I can go back and do it the other way as well. So remember we split the middle. Hey, you guys, if we can just stay with me. The notes are pretty short. There's just 2 examples. So that's when we split the middle. So if I did it this way, I would have 2 cosine squared x plus 2 cosine x minus 1 cosine x minus 1. And then I would have, so that became these 2. And I would still have to split the middle like that. So whichever way you want to do it, I don't really care. Let's just finish off this in red. So if I look at 2x squared plus 2x, what can I take out of both of these? So 2x. So then that would be x plus 1. Because I would still have 1x left here, but just 1 there. And whatever sign you have here, you want to take out. So I have to take out a -1, which would leave x plus 1. So then, since these parentheses match, I'll have one parenthesis that is 2x minus 1, and the other parenthesis that is x plus 1. So that's some factoring stuff that we covered back in chapter 1 and that you've done in the past. all that stuff with the x's in it. Now if I did choose to do it this way, then I would come back over here and I would say, okay, I know x is really cosine, so I'd have 2 cosine x minus 1 and cosine x plus 1. So that's how I would kind of do that. I would make sure I come back and put my cosine back in. But this would work the same way because I would still see here that I have 2 cosine x, so I would have just a cosine x plus 1. Here again, I'd have to take out a negative 1, and I'd have cosine x plus 1. So whether you like to keep the cosine in it or you like to switch it with the x's, it is really your call. You don't have to do them both. I'm just doing them both to show you guys both ways. All right, now if you need extra help with factoring, see me later. But when we get to this point, what have we always done in the past? Yup, split them up, sum equal to 0. It's that null factor rule. So 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. Absolutely, we want to get cosine by itself. So over here, I would have to add 1 and then divide by 2. So cosine x equals 1/2. Over here, I'd have to subtract 1. So cosine x equals negative 1. And we've done that before. We did that in the first section of this chapter as well. No. Nah. I think technically there should be a domain on this problem that just kind of got forgotten. So I'm just going to make our domain easy and say that it's just between 0 and 2 pi. So that we're just looking at around the unit circle one time. So that's where we are right now. Now we have to go to the unit circle. So where does cosine of x equal 1/2 on the unit circle? Alright, pi over 3 is one place that cosine equals 1/2. Very good, and 5 pi over 3. But then we also have to do where it equals negative 1, so where does cosine equal negative 1? At pi. So this time I've got 3 answers because I'm looking at 2 different equations. I had to get the answers for 1/2, that's those 2, and the answers for where it equals negative 1. We are going to do one more. But are there questions? So do you see what I was saying? How it connects that factoring with the solving? Okay. Is everybody good? So this one should probably have a domain too, so I'm just going to keep that same one up there. We're just going to go for one time around the unit circle for this. And in this case, we've got cosine of 2x plus sine of x. And while I can kind of imagine 2 different ways to do this, I'm going to try and guide us to the way that's a little bit less work. We either want to make everything sine or everything cosine. Now, is it possible to make sine equal to that? Maybe, but that would take a lot of work. It's going to be much easier for us to switch this so that it's sine. I'm going to write all sine. So if you look in your packet from yesterday and look at cosine 2x, remember there were 3 different choices. Which choice had sine in it?
1 minus 2 sine squared.
Very good. So we will actually just take that and set it right equal to 1 minus 2 sine squared. I still have to finish the rest of my equation, but all I did was take that relationship directly from this packet, and I chose, obviously there are a few different choices, but again, I chose the one that only has sine in it, so that I only have sine in my equation. I'm going to finish writing the rest of the equation. If there are any questions on like that substitution? So then I'm going to just bring down the plus sine x equals 0. So now we want to go ahead and make sure this is in descending order, because that usually makes a little bit more sense to us. So I'm going to rearrange it. So I have negative 2 sine squared x plus, we'll just put that 1 in, 1 sine x plus 1 equals 0. So I just rearranged it, brought that 1 to the back. Okay. Any questions so far? Do you guys still mostly like factoring it with sine? Oh, sorry.
Do we also want to put the coefficients
Off right here. Like, well, what I was gonna do was just do that factoring, like negative 2 times 1, and do the same thing we did last time. I'm not saying you couldn't work with that. I think that would give us some fractions, like if we divide it by negative 2. And we know sometimes there's like more than one way to work with the factors, especially if there's negative. But I was just going to leave it and just go with factoring the long way. But if you want to try a different way and see if you get the same answer, that's totally cool.
So we can make it 2 times 1.
Yeah, do you guys like it like this? Maybe I'm just a weirdo that I like put the x's in. Maybe that's just me. All right. So negative 2 times 1 is negative 2. So lo and behold, in order to get a positive 1, we're going to have 2 and negative 1. In order for these to like work out in the unit circle, you're going to see a lot of the same numbers coming up, but that's okay. So then I'll split this with a 2 sine minus 1 sine. And then, you know, the rest of this is still the same. So then when we split that up, they both have 2 sine x, and I just pulled out a negative to kind of get that out of there. So I took out negative 2 sine of x, which is just going to flip this sign on the inside. So this will be sine of x and then minus 1. Because I took out a negative, that's going to just flip that sign. And then I can take out a negative 1 out of both of those, so that will again flip that sign. Does anyone else feel like there's too many signs? Because there's the sign, positive and negative, and the sign trig function? Just me? What? Oh, true. So then I have negative 2 sine x minus 1. And then just sine x minus 1. Okay. What's next? Yep, split them up, set them equal to 0. So I'm just going to do this one together. So when I subtract 1 and then divide by negative 2, I'm going to get negative 1/2. And then over here, I'll have sine of x equals 1. And I'm just going to bring my answers up here. So where does sine equal negative 1/2? Yep, that's one of them. And another one is 7 pi over 6. So that's where it equals negative 1/2. And then where does sine equal 1? Yeah, I think I wrote something down wrong before. Because it does. That's right. Okay. I just wrote it down really good. Okay. That is it for examples. So you've got to do that factoring, and then you got to go to the unit circle. Combining those two things, make sure you do watch out for your domain. I think there'll be less domain changing in this one, but just in case you have to do some extra answers or go around the circle, we've already talked about that before as well. Any questions before we get to that stop box? So what are some things to remember in this section? Yeah, so if you have a number other than 1 in front, you want to multiply the first one to the last one so you can get those factors and split the middle. If it is just 1 in front, then it's kind of like a quick factoring, which I know we did in the notes on whatever day that was. 2 days ago? Monday? Okay. Remember, you need your unit circle. Remember, you want like all of the same trig functions, so like all sine, all cosine, or all tangent for that stuff. So then that is it.